watching this message, then I, Assistant Beaker, will have been long dead. Dr. Bunsen Honeydew will have murdered me, and...
What are you doing?
Stop! Don't come any closer! You've used your experiments long enough. I just keep getting hurt.
You mean getting hurt?
Seriously?
Oh, come on, lighten up. Today we're going to answer one of our most age-old questions. What is chemistry?
I wish I didn't already know.
Alright, so to find out what chemistry is, we need to start out with some basic knowledge and information about chemistry. Now, one of the most classic demonstrations about chemistry is with pre and post 1982 pennies. We burned both of them and...
What? I'm out.
No, relax. I'm not going to do it. I'm just going to talk about it. Who do you think I am? A pro like Mr. Bender? I'm not on Mr. Bender level. Besides, under U.S. Code Section 331, Title 18, we chemists are allowed to do these kinds of things, just like Mr. Bender.
Oh, okay, good.
Anyway, burning the old penny will cause it to start to glow and bend.
With the old penny, we observed a temperature change and a new odor, both evidences of chemical changes. A chemical change is when a new substance is formed from a reaction.
That is correct. Now, let's talk about the new penny. When the new penny is burned, a mysterious-looking substance just leaks right out of it. Can you think of what it is?
As Bunsen was trying to say, the zinc leaks right out of the new penny. This is because most new pennies are made mostly of zinc since it's cheaper. They have a mere coating of copper which is left over after the experiment.
Yes, as you can see, we chemists love to set things on fire. What we do when we do this is called a combustion reaction.
Yes, one example of how these types of reactions are useful is burning fuel for things like cars. Fuels like wood burning air to produce water,
carbon dioxide, and energy. For example, the combustion of acetylene has a chemical equation of 2 acetylene plus 5 oxygen is equal to 2 carbon dioxide, water, and energy.
But chemistry, thankfully, is not only about combustion. These same cars fueled by combustion can be really ugly when they oxidize. The reaction for that is 4 iron plus 3 oxygen equals some very ugly rust.
Emissions from these cars can also make acid rain, which is NOx plus water makes nitric acid. Pretty noxious if you ask me.
This is bad for marble statues too. When marble reacts with hydrochloric acid, carbon dioxide, water, and calcium chloride is produced.
Antacid tablets are made of marble too. They're used to neutralize excess stomach acid. In fact, we can do an experiment to learn more.
Oh no.
Oh, lighten up, Beaker. Add a little pop to your life.
I don't get why that pun is funny.
You will get it. Just wait a little bit. Anyway, we're going to do a very interesting little experiment today. We have a film canister filled with water. We even colored it just so that you guys would be able to see the reaction a bit better. So, we just want it. And we're going to take an antacid tablet and just drop it in. And you guys get to see the magic happen. So, you got to do this really quickly. Okay, so an interesting reaction is about to occur. And there's a little bit of fizzing and things like that. Hey, why don't you come take a closer look?
Okay.
Beaker, come on. Oh, something interesting should happen right about now.
Bunsen!
We'll be back after a quick commercial break. Oh, hi. I didn't see you there. Has this ever happened to you? Man, I really want to repel away that super annoying milk. Well, look no further to repel away your super annoying milk. You can always use Don't Say No to Soap. Remember, every single time your mom tells you, honey, I want you to drink milk, just drop a teeny tiny drop of soap in the center, and all your milk will go, ah, and run away. I'm not even joking. This product works like magic, or chemistry. Anyway, don't say no to the soap. We're not responsible for any possible side effects. Hey, Beaker, don't you think I have something interesting to state?
After the last experiment, I have nothing to state, Doctor.
Oh, lighten up. We still have to talk about the physical properties.
Oh, of course.
Yeah, physical properties help us amass our knowledge.
What do you mean?
You mean ball? You mean? Well, let me show you. Do you remember some of the physical properties?
Of course. Well, there is odor, there's color, hardness, texture, and taste, which you should be doing in a lab anyways.
Yeah, I think you forgot to tell part of the story. We need to talk about the physical properties of metal. They're good conductors of electricity and heat, they're malleable, they're ductile, and they're very shiny.
Ooh. Doctor, please focus so that we can get on with our hopefully successful and absolutely safe experiment, right?
Safe? No promises.
In any case, we need to mention all the lab equipment that is absolutely necessary. Beaker? No, not me. This. Bunsen burner.
Yeah, they named that after me because I was so cool.
If you were so cool, then why would they call it Bunsen burner? Point taken. Anyway, the next object is the condenser, used to condense a substance from its liquid gas state to its liquid state, done by cooling the substance.
So cool.
Not funny. Moving on to the mortar and pestle.
Did you mean to say motor and pestle?
No, I meant mortar and pestle. The mortar is a utensil in which a substance is crushed using the pestle. Anyways, next we have a very basic tool, a flask.
A flask? How many more? When will the fun part start?
We're almost there. This is a test tube.
Oh, what's the square root of 49?
What are you doing?
Just testing the tube.
Yay! This tube is for testing chemicals by heating or mixing them, not for math.
Oh.
Next up, we have the rubber tubing. This is used in flow lines for fluids and gases.
Are we done yet?
Last one, and it's in my hand.
Huh?
A spoon is an example of a stirring rod, which is used to mix chemicals and liquids.
Okay, finally, we're done. Finally on to the experiment. Water are we going to use?
Well, actually, we aren't going to use water. We're going to use iodine and baking soda.
Oh.
So first, I'm going to squirt 2 drops of iodine onto the clear tape.
And we're only doing this so you can see what the color looks like without being influenced by anything else. So as you can see, it kind of looks like soy sauce. Ooh, I want to eat it.
No, doctor, do not eat anything during lab. How many times do I have to tell you?
All right, the lab rules. Anyway, we have some baking soda over here, and we're also going to check out the color of this tube, just to see.
It seems clear.
Yeah, as you can see, it's just regular old clear color. So now what we're going to do is we're going to try dropping it onto this goldenrod paper. So we're going to try the iodine first.
We're going to go with, yes, first we're going to go with iodine.
And iodine's going over here.
Once again, 2 drops.
It's like a pretty blue color. Hey, let's make a smiley face.
That is also an option. And now we're going to do the same thing with baking soda onto this sheet.
Goldenrod paper. red color. It's like a blood red. It's as if the color changed somehow because of the goldenrod paper. But what would the color be like on any other paper? Why don't we check that out? So if we take the iodine and just try it on any paper, it's still blue. That shows that the starch and fibers inside the paper are the things that are influencing the iodine, causing it to change color. Color change is also evidence of a chemical change. We don't know for sure if a new substance is created or not yet, so we can't just assume if it's a chemical change or not. Now let's try trying baking soda on plain paper over here.
Yes.
As you can see, baking soda only changes color on this goldenrod paper, but not this paper.
Because it's still clear here, but over here it turned into a bright red.
So it's obvious, guys. This paper obviously has some sort of magic in it. Because if you take the iodine, that obviously doesn't have the magic. I mean, no matter where kind of paper you squirt it, if you squirt it here, if you squirt it here, if you squirt it here. Bunsen! I'm sorry, but don't worry. Iodine comes off easily. All you need is an eraser tablet, which in this case is vitamin C tablet, which you should probably have at home anyway.
Oh, I see. Thank God.
Yeah, let's check out the baking soda solution now. Now the baking soda solution only works on that paper because remember, dropping it on here and here and here and even here.
Oh well, at least this is going to get erased with the eraser tablet too.
That's funny.
What do you mean?
Baking soda doesn't get erased by an eraser tablet.
Why not?
Well, it just doesn't. That's an iodine, not baking soda.
Great.
No, don't worry. The stain still comes off, but comes up with something maybe even more common than vitamin C tablets. Lemon juice.
Oh.
So don't worry. You can get these stains off in no time. Good. Anyway, before I mess up any other clothing, we're going to end today's segment because even scientists need lunch breaks, and I'm hungry.
Thank you for tuning in and hope to see you next time.
Bye!